discussing a little bit about the different graphs. Okay, the different common graphs that we often overcome in different problems, and how from a given equation, how can we estimate the graphs? For that purpose, you have to know some of the basic graphs. Okay, for example, say if you are given any equation of the form y equals to say mx plus c, you know that this is basically a straight line with this theta, m should be tan theta, and this is the y-intercept, right? So if you are dealing with any graph, say y equals to 3x plus 2, that means straight away you can think of the graph like this. This should be y equals to 3x, and if it is given as 2, that means it will be raised by 2 units. Okay, similarly y equals to 3x minus 2 will be a graph of this type, where it will be this y equals to 3 graph, 3y equals to 3x graph will be lowered by 2 units. Similarly, if you have any equation of this type, say y equals to minus 2x plus 5, what is meant by this? Minus a straight line having a negative slope will mean that it will be directed something like this. Let us say that this is the graph of y equals to minus 2x. Now y equals to minus 2x plus 5. So this plus 5 means this thing will be raised by 5 units upward. And if you were given y equals to minus 2x minus 5, so it will be a graph like this, where this y equals to minus 2x graph will be lowered by 5 units. So this will be y equals to minus 2x minus 5. Okay, so for any given straight line, we can actually estimate the graph like this. Now another rather easy form of estimating the graph, if the particular equation is given, is using the intercept form of the straight line. That means, say x by a plus y by b is equal to 1. If you are given any equation of this form, then it basically represents a straight line having the x-intercept as a and y-intercept as b, right? So that means if you are given any equation like 2x plus 3y is equal to 6, that means 2x by x plus 3y by 2x by 6 plus 3y by 6 is equal to 1. So this will give you x plus x by 3 plus y by 2 is equal to 1. That means a is here 3 and b is 2 here. So the equation will be something like this. A is 3 units means in the positive x-axis it will be 3 units, and b will be 2 means this will be 2 units. So this is basically the equation of this line. 2x plus 3y is equal to 6. And you can also find out the points where it is intersecting the respective coordinate axis. They are going to be this is 0 and this is 2, so basically this will be 0 comma 2 and this will be 3 comma 0. So you can straight away estimate the line. Okay, so any other form also, if it is given, say suppose you are given 2x, let us take these forms. 2x minus 3y is equal to 6, 2x minus 2x plus 3y is equal to 6, and say 2x plus 3y is equal to minus 6. So that means we can write it like this. For this particular form, it will be 2x by 6 minus 3y by 6 is equal to 1. For this one, it will be minus 2x by 6 so this will give you x by 3. Now this part we can write it like this, y by minus 2. Okay, because this will give you minus 5 by 2, so we can write it like this, y by minus 2. Similarly, this will be x by minus 3 plus y by 2 is equal to 1, and this one as, okay, this will be minus 1. So x by we can bring the minus 6 here actually, instead of writing minus here. So this will give you x by minus 3 plus y by minus 2 is equal to 1. That means for this particular equation, the x-intercept will be 3 units and y-intercept will be minus 2 units. That means it will be, the straight line will be passing like this. Okay. For this one, in x-axis it will be minus 3 units, in y-axis it will be 2 units. So it will be passing like this. And for this one, both of them are going to be negative. So this is minus 3, this is minus 2. So it will be something like this. Okay. So for plotting any straight line, it is actually very easy. Like if you can, if we can develop it in the form of this intercept form, then it becomes very easier to estimate the line, and we can straight away get that where it is intersecting the x-axis and y-axis also. Okay, so this is one part. So where we are going to use this, say we are given any equation, say we are asked to draw the equation of a line, say, or say velocity time graph. Okay, the given equation is v equals to u plus at, or maybe like say in one particular sum you are getting v equals to the initial, let's say we are dealing with problems like this, the initial velocity is say 10 meter per second, and yeah, so u minus 80, that means 10 minus, yeah. So let us take the example, say given v equals to u plus 80 in equation of this form. That means suppose you are given v equals to 10 plus 3t. So how to find out the equation of this line? See, we can either refer to this form x by a plus y by b is equal to 1, where in this particular case our x-axis will be time and y-axis we are going to take v. So here we have to either express it in the form t by say a plus v by b is equal to 1. Okay, so how to do that? V is equal to 10 plus 3t, that means say minus 3t plus v is equal to 10. So minus 3t by 10 plus v by 10 is equal to 1, and t by minus 10 by 3 plus v by 10 is equal to 1. That means in velocity it will be this part 10 and t it will be minus 10 by 3. So basically it will be this line. Okay, so either we can use this form, or in for this actually it depends on the sum where like which form will be better to use, that will come with experience. So for say for this particular sum, instead of going into this working, we can straight away take it like this. Say v equals to 3t, it will be a graph like this, right? If this is v and if this is t, so v equals to 3t will be a graph like this, and if it is raised by 10 units, so that means this part will be 10 units. And in order to find out this particular point, we can simply put t equals to 0, which means v will be simply 10. So we can directly get this line. See, a ball is thrown upward with a velocity of 20 meter per second. Okay, so it goes up, reaches a maximum height, and then it again comes back. So now if we are asked to plot the velocity versus time graph for this particular journey, what will it look like? First of all, what we have to do is if we take the upward direction as positive, so v is equal to u minus gt. Okay, So in this case, v will be initial velocity is 20 minus 10 into t. Now how to plot this graph? See, first we can try with v equals to minus 10t. That means v is equal to minus 10t plus 20. So minus 10t will be something like this with a negative slope, right? So this will be minus 10t, and if it is raised by 20 units, that means this will be raised by 20 units. So the overall graph will look something like this. So this will be the velocity part, and this will be the time part. Now at t equals to 0 seconds, what is the velocity? That means it is the velocity with which it is being thrown upwards. So this will be 20 meter per second. Now what will the value of this part in the time axis? See, v equals to u minus gt, that means the moment when its velocity is 0, that means this is the time, say t naught, when it is reaching its maximum height. So when it is reaching its maximum height, we can simply use this v equals to u minus gt. That means 0 is equal to 20 minus 10t. So t will be basically 20 by 10, that means 2 seconds. And 2 seconds means that is basically this is 2 seconds. So from 0 to 2 seconds, its velocity is gradually, I mean, as this is moving up, the velocity is changing in the positive direction. I mean, the direction is not changing, right? For the first half of the journey, the velocity is gradually decreasing. So it's gradually decreasing, and at t equals to 2 seconds, it is reaching the maximum height and it's becoming 0. The value of velocity at t equals to 2 seconds is 0. Now next, what is happening after this moment, that means from right after 2 seconds, it again starts coming backwards, right? Now the direction of, I mean, if we are taking the upward direction as positive, so the downward direction will be negative. Hence the velocity is actually changing its sign. The direction of the velocity is changing, it's coming down. And so from 2 seconds onwards, the value of velocity is now being given in the negative v. Okay, that means the direction is simply changing, and it will go on till total time of flight will be 2t. That means it will be 4 seconds. So if this is 2, this will be something like 4. So from this part to this part, okay, from this 2 seconds to 4 seconds, the velocity is gradually increasing, right? But it's increasing in the downward direction, downward. So that means the entire value will be present in the downward case, okay, in the negative v8. So this is how we can find out. Okay, next we are going to learn two more graphs. The first one is, say, y equals to x square. So if y equals to x square, we already know that this will be sort of a parabola, where now suppose if we are given any equation, say y equals to x minus 2 whole square and y is equal to x plus 2 whole square. So x minus 2 whole square means at x equal to 2 we will be having this parabola. So it will be something like this, and y equals to x plus 2 whole square means at x equals to minus 2, if we put x equal, if we put x equal to minus 2, then we are going to have minus 2 plus 2 0. That means we are going to have this thing for this particular graph at x equal to minus 2. So that is why the graph will be something like this. So if we are given any particular equation, there are say we have x square plus say 4x plus suppose 9. We have this particular equation. How to draw the graph of this thing? There are different methods actually, but one of the easiest methods which I feel is first let us express it in the form of something whole square. So that means y equals to x square. See, if it is x square plus 4x plus 4 and we are left with 5, that means this is simply x plus 2 whole square plus 5. That means the graph will be, first let us, the approach should be some like this. First we have to uh, draw this graph y equals to x square. From there we need to estimate that y equals to x plus 2 whole square. Okay, now once we get y equals to x plus 2 whole square, then we can write down y equals to x plus 2 whole square plus 5. So this is how we are going to reach the final graph for this particular equation. So let us start with this thing. So y equals to x square means it will be something like this. Done. Y equals to x plus 2 whole square means at x equal to minus 2, that means it will be at x equal to minus 2. So graph will shift 2 units on this part, and then from this graph that is being raised by 5 units, isn't it? So this particular graph, that means if this is y equals to x plus 2 whole square, then if this is raised by 5 units, sorry, so that means this will be the graph. Okay, so ultimately the nature should be something like this. It should be something like this. So at minus 2, okay, and what will be this point? This will be simply if we put x equals to 0 in this equation, it will be 9. So this is 9. So if we are given any equation where, this is y, this is x. So if we were given like s is equal to this expression, okay, x square plus 4x plus 9. Okay, or rather displacement versus time graph say. So s is equal to t square plus 4t plus 9. In this same way we can get it. So we are going to neglect the negative time part in that case, because we are only considering time as positive. So this will be minus 2 and this will be 9. Okay, similarly if we had a graph like this, say uh, velocity, okay, is given as, let us take another example. Now very often we come across relations where it follows the form of this type: y equals to root x. Y equals to root x, the general graph is given like this. Okay, so and similarly we can let's say y equals to root x. If we draw say root x plus 2, that means it will be something like this. Root x minus 2 will be something like this. Okay, where it will be shifted down or up by 2 units. Okay, so let us take an example. Say we are asked to draw the three graphs related to a motion. Say there is a freely falling ball. Say the ball is falling from a height of 20 meters with the initial velocity 0. Now if we take the downward direction as positive, suppose we are asked to draw the graphs of velocity versus time, then say x versus t, that means say displacement versus time, and the velocity versus displacement. Say these are the three graphs we need to draw, and we are considering that the downward direction as positive and the level of this maximum height, the displacement is 0. Okay, so that means as it will be coming down, the displacement will be increasing, and since we are taking the downward direction as positive, so the displacement will be gradually increasing. Okay, so if we look at the equations first, the first equation that we can write is v equals to u plus at, because for this downward journey the velocity will be increasing. The initial velocity is 0, so that means v equals to at. So v equals to simply 10 into t. That means the velocity time graph will be simply this, where at the end of the journey, that means when it is going to strike the, how much this will go on. Okay, so for that purpose we can find out the time of this journey, which will be, say, if we take h equals to ut plus half gt square, and since this is 0, so we can write it as 20 is equal to half into 10 into t square. So this will give us t square is equal to 4 and t equals to 2 seconds. That means this will go on till 2 seconds. And the maximum velocity that we will be getting is, that means v equals to 10 into 2, it will be 20 meters per second. So this will be the velocity time graph for this particular journey. Okay, and here the given direction is, we are given that the downward direction has to be taken positive. Okay, if it is given the other way, then the entire thing will be in the negative sense. Its velocity should be decreasing. It would have been something like this. If we had considered that the velocity is gradually, the upward direction as positive, then the graph would have been like this. The velocity would have increased, but since we are considering the downward direction as negative, so it's increasing in the negative sense. Okay, but here it's given that we are dealing with a situation where we are considering the downward direction as positive. Okay, so this graph is done. Next, displacement versus time graph. Now displacement versus time graph, the equation that we are going to use is x equals to, that means simply s is equal to ut plus half at square. So here the displacement, if this is x, initial velocity is 0, so this is simply half gt square, which is half into 10 into t square. So simply the governing equation will be x is equal to 5t square. So this we have already done the graph of a parabola, so definitely the nature of this graph should be something like this. Okay, where we will be doing it for 2 seconds, because the time taken for this ball to reach the ground we have calculated it as 2 seconds. Okay, yeah, so time taken will be 2 seconds, so it will go on till 2 seconds. So this is x versus t graph, and here also the definitely at t equals to 2 seconds the value is uh, 5 into 2 square, that means simply 20, and that is what it should be because the given height of the tower, or it's, I mean, it's given that the initially it's falling from a height of 20 meters, so that means after 2 seconds it should have covered 20 meters. Okay, so it should be, the graph should be till this portion. So wait, anyway, you can limit the graph till this part. Yeah, okay, so this is done. Next, the v versus, we are left with the last graph, that is v versus x graph. Now how to get this graph? V versus x means, so we have to first get a particular equation relating the velocity and displacement. For that, see, if we use this equation, v square equals to u square plus 2gx, okay, 2as, that means here it is g, this is 0, so simply v square is equal to 2gx. Now that means v is equal to root over of 2gx. So you see that velocity will be proportional to root x. That means what type of a graph should it be? The nature of the graph should be something like this, as we had done, that y equals to root x means the graph will be like this. So since we are getting v equals to root over of 2gx, it should be something like this, and it should be running till the value of x should be running till how much? Because this is v versus x, what should be the velocity if we put x equal to 20 meter? And actually we already know the value, that when it is going to strike, did we calculate it, did we calculate the velocity? Yes, it is going to strike at 20 meter per second. So this should be, actually the value of x should be 20, and this is also 20, and this is also 20. And we can check it, like v equals to root over of 2 into 10 into 20, so this is giving us root over of 400, which is 20 meters per second. Yes, so this is how we should plot the graphs. Okay, okay, let us take one more example where say, let us take two cases where this is, say, a building having height h. Okay, same case. Now in the first case, let's say that the ball is an object, or a ball, say it's thrown downward with an initial velocity 0. Okay, and in the next case, let us take that the object is thrown upward with a certain velocity. Okay, say some velocity, say maybe 20 meter per second, or whatever it is, there's some velocity. Okay, now in this particular both the basically the we are taking the same height. Okay, now if we are asked to plot the uh, distance, not displacement, okay, distance versus time graph for both the cases. So this is distance versus time graph for both the cases. That means for this particular case, as the ball is coming down, its velocity should be increasing. So here, since we are not dealing with the vector quantity, uh, so simply, I mean, this direction as positive or this direction as positive, it matters less actually. Although the value of g is definitely going to affect the value. But let us try to understand. See, we know that how is the distance related to time? Definitely the governing equation is s equals to ut plus half at square, like this. Okay. Now that means the distance versus time graph is it's a square law. That means it should be some quadratic equation, and it should be increasing in nature. Okay. So increasing nature means this also means it is increasing. This also means it is increasing. This also means it is increasing, isn't it? So all these three cases gives us increasing functions, right? But without even going for the exact equations, how to estimate the nature of the graphs? That means whether it should be first one or third one. Generally, I mean, we can uh, neglect the second case because since we have understood that s is equals to t square, that means it will be some parabolic nature. I mean, it should not be a linear function. Linear means straight line. So definitely we can eliminate the second case. Now for this particular case, we see that definitely the distance is increasing, but during its last journey, okay, I mean, see, the whatever I'm explaining, this definitely can be done using a mathematical approach. But what I am explaining now is like without going into any exact mathematical approach or exact mathematical equation, can we estimate the nature of the graph? Yes, that's what I'm trying to explain here. So you see that during the last portions, say for the last duration, okay, last time interval, if the nature is like this, okay, that means as the as time goes, the speed is gradually increasing, okay, and the it's covering more distance, isn't it, compared to, say, this is also 1 second, this is also 1 second, let us assume it. So for this second it covers lesser distance, and for this particular second it covers much more. This only happens if the velocity is gradually increasing, isn't it? So in which case is the velocity increasing? This particular case. So for this particular case it will be like this, but for this one the velocity should be decreasing, isn't it? Because you see that for, let us take this 3, I mean, this is also 1 second, this is also 1 second. So for this particular case, you see the velocity has increased this much, but for this particular case the velocity has decreased. I mean, the distance covered has only been increased by this much. That means for this particular case, as it is reaching its maximum height, the velocity has come down quite a lot. So that means during the last moments of its journey, it will cover very less distance with such a nominal value of velocity, isn't it? So that is why as the time approaches the time of flight, I mean the time taken to reach the maximum height, the distance covered will be very less. Okay, but here also actually it is not proportional to that root x thing, isn't it? Because in one case it will be s equals to, I mean, if we come to the mathematical approach here, because we have to relate the mathematical approaches along with our, the normal logical explanations. So in this particular case we will be dealing with an equation with u I mean ut plus half gt square, because the gravitational force is helping the ball to move and its velocity will be it will help to accelerate and the velocity will be gradually increasing. So this will be a parabola. You see that t square, the coefficient of t square is positive, so it will be a parabola opening in the upward direction. Okay, and for this particular case, definitely s equals to ut minus half gt square or half at square. So for this particular case, you see that the t square, the coefficient of t square is negative. That means the parabola should definitely open somewhat like this, isn't it? So that is why it should represent this part of the journey. Okay, that is why the nature of the graph for this first case is actually like this, u-shaped upwards. That means it's gradually increasing like this, and for this particular case it's gradually increasing like this, but the rate of change will be slower. Okay.